We're going to get this going. Hello, everybody. Welcome, everyone. We're really glad to have you here. Hopefully, you were able to get a snack, make a friend or two. How many people are here for the first time? Nice. How'd you guys find us? Any brave souls? Speak up on how you ended up here. Friend, meetup.
Free food.
Free food. There you go. You just smelled it. I was just walking down over there. Yeah. Well, we really have to thank Barry for hosting for us. And John Van Hetteren is here with Varian. You want to say something?
I'll just thank my own employer, the one who pays me my paycheck. Very pretty decent employer, and we want to congratulate them for giving us use of this facility without countless insurance forms. That would happen if you were in many other places. So, thank you.
Thanks so much, Varian. And also, tonight's food sponsor is Daitan. Is Henrique around? Yeah. Do you want to give your pitch?
Well, I wouldn't call it a pitch, but thank you for hosting. And thank you for allowing me to say a few words. I tried to hold it until the end, but Roy got me excited, especially when he mentioned RS-232. That's how I started my career. But anyways, my message to you was software development has never been so easy, and has never been so complex. Let me explain to you what I mean. As I mentioned, I started writing device drivers for Linux, RS-232 drivers for that matter, in C. So I had a lot of fun with pointers, and all sorts of esoteric concepts that took me months to figure out. And I thought it was very complex. Today, I sit down to play with my computer on the weekend and show my kids some languages, and I look at Python and JavaScript, and I'm like, well, this is kind of easy, all right? But it's misleading, right? Because today, you look at all the different options we have to solve any particular problem, and there are so many, it's very complicated, it's very complex, right? Back when I started, I'm not saying how many years ago, we had C, Java, shell scripts, that was fun, and some early HTML. Today, how many languages? How many different services on Amazon? 150. I lost count, but it's more than 150 by now. Google and Microsoft follow closely, right? How many different open source databases? Anybody database people here? Which one's the right one for you? For your project? So many options. So all these options break complexity because you have to know all of them. Right? But they also make it so much easier to develop projects if you know the right tool for the job, right? So that's my pitch. We've been around for 15 years developing software. We've seen a lot of these tools. We started in telecommunications. Now we do finance and big data and engineering offices in Brazil and in Canada. And we've seen most of those tools. If you're trying to develop something, or if you're trying to make a tough design decision, we've probably seen it a few times. We had hands-on experience with all these tools. So if you need help with software development, come and talk to me or Catherine back there after the presentation. Okay, thank you.
Thanks, Henrique. Thanks so much for that nice feedback. If you haven't noticed, there's a book swap over in the corner. Swing by there when you have a minute before you head out this evening. Grab a book, drop a book off. Just spread knowledge. We're big fans of that here at SVELC. And then also at the end, we'll hear from all you guys. If you are either looking for a job or if you have a job opening that you're looking to fill. So keep those in mind, and we'll share at the end. And I'm going to invite Bruce up to introduce our speaker tonight.
All right, so one of the things we do as a group is we were brainstorming topics that we thought would be interesting to the group. And blockchain came up, did some reach out to the network, and a good friend introduced me to Sam. I use the American version, Sam Su, and who has co-founded a blockchain startup and speaks very well about blockchain. So tonight's topic is going to go through quickly, and then lots of time for Q&A. So be thinking about what your deeper questions are about blockchain. With that, I'll turn it over to Sam.
Cool. So just to reiterate on the structure of today, I think there's a very varied room here from the few people that I've spoken to already. And so I want this to be valuable for you guys. And so whatever questions you have, even if it's like extremely not technical or pretty technical, I can't go fully technical just because I'm not a full-time developer. But I do have a very diverse background, so I do have some coding. I am an entrepreneur. I do have a startup, but I'm also an attorney. And so I can attack all of these questions from multiple different perspectives. So that should be, I think, kind of a unique value add for you guys. And the reason I do it that way is because that's actually how I got into blockchain in the first place. Back in 2016, I had a friend. I don't know if you guys have that guy, but like I had a friend who was that guy. His name was Joe. And Joe would not shut up about blockchain. Every single time I saw him, it was blockchain this, blockchain that, all the time. And so one day I was like, all right, Joe, let's do this. I sat him down and I grilled him for 6 hours straight. I hit him with every single question I had. And at the end of it, I was like, all right, this blockchain stuff is pretty cool. I guess I'm going into blockchain. And since then, I've been working full-time in blockchain on multiple different startups covering a pretty wide range of topics within the blockchain ecosystem. More infrastructural stuff, like the stuff I'm working on currently, to more like dApps. I don't know if you guys know what dApps are, but they're essentially just decentralized applications that are more user-facing, or like end-user-facing. And so I've covered a lot of that. And I go to a lot of conferences. I just went to the Ethereum Developer Conference in Osaka a few weeks, was it a month ago now? Like a little recently. And so I'm pretty well connected in the space. So if I don't have the answer to the question, I can get you the answer. So let me just jump into this. So I'm gonna, as Bruce said, I'm gonna go through this really quickly, just so that we all have the same vocabulary for asking the questions, and then I'll really just open it up and field as many as I can. If this clicker works. Cool. So we'll cover basically both blockchain from a technical perspective, but also more for why it's so popular. Because it's not the tech that's catching on, it's more the mentality and the ethos and the paradigm shift that it's causing that's making this catch on, mostly among younger, technically savvy people. And then we'll go into, as I said, definitions, but then I want to give you guys a lot of the general use cases, but I also want to drill down there too. So we'll introduce something where you guys can mention something. I'll try to explain how it works and why blockchain is relevant, or I will honestly call out projects where it is not relevant and they're just doing it for hype. But then at the end of this, I want to leave takeaways for different groups of people. I guessed at these, but if we have more, I'll make it up as I go. But for engineering, leadership, like management folks, I'll try to have something, as well as the business leaders, as well as just normal developers who don't want to think about how their code is being run in the world, just in their own system. So yeah. So as I said, the tech is interesting. The tech is actually pretty cool. If you're a technical person and you want to go research how things work, you can. That's a huge rabbit hole you can kind of just find yourself going down. But I think a lot of the hype behind the blockchain kind of movement has been more about the mentality of what can this do for us? And really, the last sentence, like the last bullet point, it feels like we're affecting the world around us. So that is why the younger kids are really hopping onto this. It's like, I wasn't here to make the problems of Social Security. I want this system where it's provably verifiable, and I know exactly how much I contributed in that. And it's already programmed in that I would get my payout. And so things like that, where it feels like it gives the user more control, and it feels like all of the cards are kind of open on the table, where nothing's being hidden. There's no like black box that all of the decisions go through. And so those are the two main kind of like pragmatic reasons, the philosophical reasons why it's actually not. So anyone want to take a shot at defining blockchain?
Immutable ledger.
Mutable ledger. Anyone else? Cool. But it is an immutable ledger. So immutable means you can't change it. Like you can't go back and like undo something. You have to put in a new thing that says, I want to undo that thing, but you're adding a thing that says undo that prior thing. So it's an append-only kind of structure. But a blockchain is really just a data structure. I know you've heard the word ledger. A ledger is just a list of things that happen, but imagine a list of things that happen and you can't go back and delete something. You just have to add a new one that says like, oh, refunded a transaction instead of undoing that transaction itself. Cool. But what it gives us, that technology, what it ends up giving us is the last two. You can now do a trustless global state of a thing. So anyone who works with state, anyone not know what state is? Like computer state? It's just the truth of the world, like one truth. There's one global truth in a blockchain, and that is the blockchain itself. And the kind of technical cool stuff is how you get the one truth accepted by everyone. And that's something called consensus that we'll go into. But the second thing that's kind of cool from the technology here is that you can have digital uniqueness, which was not really a thing. If you remember like MP3s, like Napster back in the day, if I had an MP3 and I sent it to you, your MP3 is just as good as my MP3. They're like, these are not unique in any way. But using cryptography, the magic of cryptography, you can actually verify uniqueness. And those are now most common in something called a non-fungible token. Means that fungibility is actually another term. So if I have $1 and I give it to you and you have your own dollar, we now have $2, but those $2 are pretty much interchangeable. They're not identical because they all have serial numbers on them, but no one cares what the serial number of that dollar is. If it's a valid dollar, they will accept it. But in the case of certain things like the non-fungible tokens, your particular dollar won't be accepted where this particular dollar may be. So that's digital uniqueness using cryptography. You can go into that. I know you guys probably know the general structure of a blockchain where there are something called transactions. And a transaction is basically just a thing you send into the blockchain to change something, like an entry into the ledger, essentially. Or if you're a programmer, you can think of it as like a function call. So the function call is something that you package up and you send as like a package into the blockchain, and then that does something. It has some effect. And those transactions get grouped up into a batch of transactions that ultimately gets added into the big chain of things, and that is the new block added into the block chain. Anyone have questions on that so far? We're actually almost done with the whole intro and the definitions. You're going to hear the term nodes. Nodes in a blockchain ecosystem just means a computer that is fully synced up with the current global state of the blockchain. You've heard the term mining, so mining of Bitcoin. What that is it's actually a competition. It's a competition between all of the different miners to try to be that person who gets chosen to add the next block into that blockchain. So if all of us are competing against each other, one of us will be the one to add the next block. And that one person, for winning, they get all of the transaction fees, like the gas fees you may have heard of, as well as they get newly minted Bitcoins, or whichever blockchain you're talking about. But you get 12.5 Bitcoins for adding a block. And currently, I think it's like $6,000 or $7,000 or $8,000 per Bitcoin. And so 12.5 of those you get for successfully adding the block. That's why there's so much competition to be the best miner, to have the most power. Because as we'll talk about on how consensus works, whoever has the most computing power will win that. So there's really two, like you don't have to read all that. So there's really two different types of consensus. One is called proof of work, and that's the one that you guys probably are familiar with, where it's using a whole bunch of electricity, where everyone's trying to buy GPUs to kind of get their hash rate up, so they can have the most kind of like arms power to bring into the mining battle. And as I mentioned just now, whoever has the most power will win, like probabilistic. You'll be the one to solve it first. But then people didn't like parts of that. They didn't like the competition for that. They just wanted a random structure where it doesn't matter how much computing power you have. We wanted to have your probability of being chosen to be kind of in correlation with how much you want the system to stay good. So they came up with something called proof of stake, which basically means if you have a lot of money invested in the system, you're probably not trying to ruin your own system. And so you are more likely to be incentivized to do it properly, and so you have a greater chance to be chosen. And then people came along and said, even that's too out there. We just want our friends and us. We trust each other. We have contracts in place, and so if they are malicious, I'll just sue them in court. So that became a permissioned blockchain, and so that is not a public blockchain, but you have to be kind of verified in, and you also have to pay a lot of money, and we can talk about that as well. I believe this is the last definition slide. So a smart contract is essentially just a way to add information into your transaction. You can add some code into your transaction. This is oversimplifying, but add code into your transaction so once it's on the blockchain, you can run that code over and over again because it's already on the blockchain and it's immutable, so it's always there. And an application that does that is a decentralized application. And the gas I mentioned gets included with every transaction. And a wallet is just a thing that helps you manage interacting with the system. Cool. That's it for definitions. Anyone have any questions on terms they've heard that they want to be defined? Okay. Cool. So I could go deeper into this, but I think I won't. Let's just keep it more interactive, because I do want to hear what kind of questions you guys have, and we'll kind of veer the conversation in that way. Does anyone have a question about blockchain in general, or like what do you guys want to learn?
I'm in the medical device industry. Most of our partners have no benefit from trying to alter data. There is no financial benefit to that. There is some need for security, but immutability is not a big issue. So there are those who advocate using blockchain even though we don't have this need to be immutable. And I understand it comes with a processing penalty. Blockchain is not as fast as some other methods. And can you address the trade-off between when do you need the benefit, like when does the hit in performance justify immutability or whatever benefit?
Just to summarize that question, I'm a medical device manufacturer or company. My clients have no use for blockchain, or they don't need to worry about getting their data attacked, at least from themselves. Blockchain has a penalty because it's not as efficient as some systems, mostly centralized systems like the ones that people use on a regular basis. When is it worth it to use blockchain? Is essentially what it is.
Yeah.
Okay. So blockchain really goes back in that situation, I think, to the shared state. So if you're a device manufacturer and you have made something and everything from your end is good, right? Let's say that system works fine, but that device has to then interact or interface with a different system. And so you could just do an integration directly with that second system. And that would work, but what if you have to connect to every system in the world? And so that would be impractical to do by having your company interface your device with that. So it's really a standards question at that point, where if you can set, if there is like a medical blockchain, for example, as like a base layer, and then your product complies with the standards that that base layer sets forth as like the standard, anyone who wants to use that device can now automatically be compatible with your device. And so, for example, if there's like a medical records system that your device has to interface with or like give information to, you can have that done pretty trivially. And to also verify things like ownership, like who was the one to use that device on themselves? Like if it's like a blood tester, whose blood is it? Like those kinds of things where it's not about the system itself, it's more about how that system interfaces with other things, how you manage global state, and how that interacts with the physical world. And the physical world portion is actually kind of tricky. There's no good solution yet, but a lot of people are working on that. Is that a good follow-up?
Sort of. There already are protocols for exchanging medical information, and the actual medical stuff can be encrypted, so we can deal with privacy. The present economic model are that individual hospitals sign contracts with providers. So it's not like you're ever going to talk to the whole world. You're going to talk to those entities that have signed a contract with you. You may have several thousand contracts, but you won't have several millions or you won't have billions. So I'm just wondering if the scale, like...
Sure. That's actually regarding the public versus the permission. Remember I mentioned permission blockchains? That's the perfect use case for a permission blockchain, where everyone has their like blood in the game. What is that phrase called? But everyone's incentivized to keep the system up and running because they don't want the system to go down. And then they can also be very large companies that will, perhaps stake lots of money to join the system, as well as put their reputation on the line by joining the system. And so they would be incentivized to keep the system up and running. And in that situation, you don't have to worry about slower things because permission blockchains can run much faster than the public blockchain. So you should look into, for example, Hyperledger.
Like which?
I'll go into this.
Okay.
May I make a comment
Yes,
on
please.
his question? Because I think
You guys
a couple
are
of things got mixed up here. Blockchain does not encrypt data.
Is it?
Blockchain simply verifies the chain of custody. This is its utility. It's not what is in the documents that you think might. So first of all, it doesn't eliminate the need for your company to encrypt its documents according to all the laws that are applicable. This is number one. Number two, the computational overhead does not have to be high because one doesn't always need to go all the way back to the original block. When you verify the chain of custody for a notarial application, you need to go back 2 or 3 or maybe 4 blocks to verify that this notary was authorized by the judicial authority in his or her country and whatever. You don't need to go back all the way to the beginning of time as we do for cryptocurrencies. So I think it would be useful in this presentation if you could highlight the differences between the cryptocurrency use case and other use cases, which in the view of some of us are more important than the cryptocurrency case.
Okay, I'll do just that. So I'm going to break down 3 different kind of buckets or categories of use cases. One is the public blockchain-based cryptocurrency, or a digital asset, more generally speaking, or a virtual asset. Bitcoin is probably the most famous example of that. So what Bitcoin wants to be is a currency. It wants to be a store of value or a currency. It's based off of a public blockchain. And its ultimate goal is to become a global currency. And so if you could think of like Earth coin or like an Earth dollar, where all of the different nations are somehow incentivized to play well with each other in the same system, that's the ultimate goal of a cryptocurrency. And how you achieve that is, we can go deeper into that as well. But for example, the reason why Facebook's Libra project was so big was because it's an attempt at doing that, but no one trusted Facebook to lead it.
No one trusts Mark Zuckerberg.
Yeah, exactly.
Explain what pure means, what is a pure currency?
That's not a technical term. It just wants to be a currency. It doesn't necessarily want to be like a platform for an app, for example, which is what this wants to be. So this is Ethereum, which is probably the second, it is the second biggest blockchain project, but it's the largest decentralized application platform. And so before Ethereum, so between Bitcoin and Ethereum, so Bitcoin was 2008 or 9, Ethereum was 2013. So in that interim time, people tried their best to use something called Bitcoin script, which is like a very simple programming, like a way to program your Bitcoins. And they came up with many projects that tried to do more useful things than just be sent from one place to another, like conditional sending. Like if something happens, then send it. So things like that. But when people had different use cases for that programming portion, they would have to create a new project entirely. And so a new platform entirely. They would have to essentially fork Bitcoin and turn it into like Litecoin or Bitcoin Cash, or like a new system in its entirety. And someone thought that was a very inefficient way to do things. If you know people are going to try to make a bunch of projects, why don't you just make that easy and make a platform where the point is to make a different project? And that's what Ethereum is. And that's kind of been the base of a lot of the ICO things that happen, where people were like, I have a project too. I'm going to do this, and I'm going to go raise some other cryptocurrencies and cash that out to fund my project. That's what that was about. There's a lot of projects here. This is only a tiny sample of thousands of projects. So Ethereum is not a currency. It can be, but it's not trying to be. It's trying to be a smart contracts platform. So a platform on which you can do all this stuff. To the point where they actually created their own programming language called Solidity. There's actually multiple programming languages that you can use to code on the Ethereum virtual machine, is what it's called. But Solidity is by far like 99% the most popular. And it's very simple to learn. We'll get into that a little bit at the end as well. It's very similar to like JavaScript, like almost like typed Java. We'll get into that.
Sam, could you give a quick example of a smart contract, of just one use case?
Sure. A use case?
An example of a smart contract.
Do you want to see a smart contract?
Why would I have one?
Why would you have a smart contract? It's just, so why would you have a class in a programming language? Because you want to do something, but you want to do it like over and over, right? And so you would kind of encapsulate that into a smart contract, which lives in a publicly accessible place. And then instead of creating that code from scratch every time, you just kind of call that by sending out a transaction. And so every time you send a transaction, those become like the parameters that go into the function. And then that runs through the contract code, and that does something or changes something. Did any of those people on that? Okay.
So it's like repetitively ordering napkins as smart contract, or is that just the book?
You can make napkin coin and do an ICO, yes. Like, is ordering napkins repeatedly a smart contract worthy kind of piece of code? It depends. It depends how complicated ordering a thing is, but there's also a cost to deploying a smart contract onto the network. So another way to think about Ethereum is that it's a distributed compute system. You can think of one really slow, not that good computer distributed across the world. And anybody in the world who kind of plays by the rules can use that computer to do whatever they want. And that's essentially what Ethereum has become. It's like a global compute system driven by transactions. And those transactions to execute are driven by monetary incentive for the miners to actually run the code. So that's a more technical description.
Yeah, quick question. So what do you mean by it's multiple current cryptocurrencies? So are there just a number of currencies on top of Ethereum?
Yeah, so a cryptocurrency is basically just a token that you can generate. So let's say you have a function and you kind of say like, I have a counter, or like I have this thing that gets generated, like you can think of it as like a web token, right? Like I'm gonna, in my project somewhere, generate this web token that will do a certain thing, and then it'll go away at a certain point. So in that, you have to generate a thing, use the thing, and then get rid of the thing. And so those are essentially tokens in the cryptocurrency system, which is what people end up trading on an exchange because they want to be able to do what that token lets you do. So if that token, for example, is like a ticket to a movie or a famous show or whatever, that token has value for a certain time. It gives you access to the thing, the event, and then once it's done, you can kind of discard it or maybe, I don't know, send it somewhere else into like your keepsake box or whatever, and you can kind of keep it. So that's an example of a token, and those and the rights that they give you are the cryptocurrencies, which have some value that people are kind of trading back and forth on exchanges. Okay. And Ethereum's not the only one. There's hundreds probably of different platforms that were like, that's a great idea, I can make one too. And so a lot of the other ones have emulated a lot of what Ethereum does, but they've tweaked a lot of things to either make it more performant, make it, I don't know, like faster, give it higher throughput, only let their friends use it, whatever. So all of those permutations have become new blockchain platforms as well. So like EOS is an example, NEO is an example from China, and there's many more. And then one other thing that Ethereum kind of is known for is that, as I mentioned, that one shared global computer is not that good. It's not that fast, it's not ultimately that performant, it's not like a supercomputer. And so what people have done is they've thought of interesting ways to kind of use what they have, not change it, but to make it work better. So for example, instead of sending one transaction per ticket in that example, you can kind of batch those up into a show. So one show becomes one transaction instead of every ticket being admitted being one transaction. So those solutions that kind of increase the throughput by batching things in certain ways. Those are called layer 2 solutions in blockchain, where layer 1 would be like Ethereum itself, and like the other things that are similar to it. Cool. I know that's a lot for some of the people that, who here is a technical, like an engineer? Okay, so a good number. Who is completely not an engineer? Like the furthest from an engineer. Okay, cool. So those are easy questions, so please ask my questions.
Did you say you had a smart contract you were going to show?
I could. So what you can do is go to, so Ethereum has, so remix.ethereum.org is basically an online IDE where you can go and play with code. And it runs in the browser, you can edit it there. You can actually have, it auto-populates in like a GUI for you if you have like inputs like in your smart contract. It'll just auto-generate you like a input area. And so you can kind of tinker with that. So the default smart contract here, you can't really see it. And I don't think it will help you that much. I probably won't go line by line through the code and explain it because you can, it's actually, there are a lot of tutorials online because a lot of these ecosystems are very open source. And so the ecosystems themselves are incentivized to get more developers on their platforms versus their competing platforms. And so this code, the language is Solidity. And so you can just Google Solidity code example and they will have many walkthroughs, many tutorials on how it works and why you do things. Any non-technical questions in case you're completely lost? lost.
What's blockchain's biggest barrier? Because it seems like it's been like new and cool and upcoming for kind of a while now. And
So the question is, what is blockchain's biggest barrier? Kind of why isn't it even bigger? Like why is everyone here not using it on a day-to-day basis for everything? The short answer is UX. The UX side of it, like user experience side, using it is not that simple. So, for example, if you've ever, and who here has ever bought or used a cryptocurrency ever for any reason? Yeah, so I would say like 4 people out of everyone here. And the reason why is because one, you probably don't know exactly what it does or why you would want to do it. That's like the biggest barrier to entry, like people don't know. And 2, even if you wanted to, you don't know how to. And so that process of kind of letting you understand how it works, but more importantly, making you feel comfortable with actually doing that is actually very cool. So it's not really the tech, because the tech works, but it's more like mindshare, kind of getting people to wrap their heads around it, but then to trust that it will do what it's going to do instead of like nagging.
So based on that, what emerging applications are about to become more popular? What do you think the mainstream applications of blockchain is? It's not, I mean, it's popular in the tech community, it has a community of things. What are the things that are about to be much bigger than being under the radar for most people in your opinion?
So what's the next big thing in blockchain is kind of the question I'm hearing. So I would say the next big thing in blockchain is actually finance related, because if you're about to make millions of dollars or billions of dollars in some cases, you are very incentivized to figure out how to make that work. Okay? If someone says like, learn how this thing works, and if you do that right, you will get $1 billion. $4 billion, which has happened, then people are very, very, very incentivized, even if they have no technical background, even if they're guys from Burning Man, like they are very incentivized to go learn how everything works, who they need to go talk to, how much they have to pay that person to do that thing for them instead of their competitor, and so that ecosystem is very lively. But in terms of non-financy things, there aren't that many things that are very useful. And so a lot of the use cases that you would feel familiar with are more on the permission side. So it's not quite the public stuff. It's not quite like the whole like trustless ecosystem thing. It's more like when Walmart marks all their lettuce with blockchain. That's useful. When tracking fish across, like from like ocean to table, like that stuff is usable, and that's only because the companies themselves are trying to push it, because the companies themselves have a financial benefit by using it, by saving costs, by not throwing out as much stuff for whatever reason. So for the end, like retail consumer, we're kind of far, like we're not there yet. So this is an example of the DeFi movement, the decentralized finance movement. Oh, sorry.
Yeah, so for Ethereum, people have been enthusiastic and trying to, say that if you could use it for everything. But in your perspective, what are the use cases that make most economic sense?
So it's a kind of permutation on the like what's usable, what's paid, what's coming up question, and I think it's still just finance stuff. So financial derivatives are becoming a thing. Stable coins, as some people know about, those are more financial primitives. So they're not cool new companies that are doing interesting things yet. They're the companies that are doing things that were done in like the 1500s, but on blockchain. And so we're kind of there. Or like you can think of it as like mid-80s internet, where people are kind of like figuring out how things work. They're putting things together. They're kind of trying it out in the market. But the market's just like, I don't get it. I'm just going to use my phone, like instead of the internet. So I don't know if that answered your question, but finance stuff is catching on because more people are willing to use a thing, even if they don't understand it, as long as they're guaranteed to kind of safeguard them, but they make money by doing it. There are others, but they're not that great. So we'll go into some of those in a bit. But this is an example of all of the things that kind of have some adoption, but this is all in the finances side. So, but they all do different things. But as you can see, it's like investing or like holding your cryptocurrencies because actually one downside in terms of UX is that everything's kind of based off of your private key, like a cryptographic private key. So if you lose that private key, there's nobody in the world that can recover that for you. So that's terrible UX, right? Like imagine how many passwords you've lost in your life, right? But now make that not a password, but like a random set of like 32 like bytes, right? Like it's like a very like unhuman readable string that you have to save somewhere. But you can't just copy paste it into like a notepad file, keep it as a text file on your desktop. Or you can't like write it down, you know, like you don't want to write it down on like a Post-it. So there's really like even something as simple as that is a huge problem that does not have a great solution. And that's one of the main reasons that I'm saying UX is a very big issue. One of the biggest and actually most successful projects in the blockchain space, you may have heard of a project called Coinbase. So Coinbase is basically doing that and kind of addressing a lot of the UX issues by kind of just letting you use a credit card or like link your bank account, turn it into crypto, and then they will let you recover your passwords. But it's a Coinbase password, not like your actual private key. So in the more hardcore cryptocurrency community, they don't use Coinbase because they don't have any control over the cryptocurrencies themselves. All they have is like a Coinbase password, like username password. And so a lot of the benefits of not trusting someone to do things for you is completely lost because you're completely trusting Coinbase. So it's like a philosophical stance that people take. And so a lot of the current ecosystem is still on the hardcore crypto side, and they don't want to go onto like the Coinbase side. And so that's another thing holding back the UX improvements, but people don't want it.
So let me qualify my question. Usually you don't do things where the return is less than 10%, right? Because it doesn't make economic sense. There's a cost to mining, right? To keep the blockchain up and running because it doesn't have to be up. And it costs at the very least electricity, part of the cost of devices and labor involved. So you would never use it for applications where the return is less than the cost of keeping the whole system up. So if that's the constraint, what use cases does that disqualify? Or what are the use cases where the return or the value generated is substantially larger than the cost of maintaining the function?
So that's actually so the question is, it wasn't really a question, but the comment was, it's irrational to spend more money on a thing than the value you're getting. What is the value of mining, and when is it worth mining? Is that a fair summary?
Sure.
Okay. So the people that use the blockchains typically, and the miners are usually very different people. They're different sets of people. The miners are typically large operations, not in the US, because electricity is actually expensive in the US, that are in places that have subsidized electricity or extremely cheap electricity, like renewable energy places, like next to a hydro dam, they'll set up a lot of mining operations, or places where you don't have to pay for cooling, like Iceland is pretty big. They do a lot of mining there. And places where electricity is subsidized, like China, where the Chinese government will just give you free electricity for mining. And so in those situations, they actually lower the bar where it's almost like hard to break into mining. So no one here probably can run a profitable mining operation. Myself, but it's really not. And so there are kind of little inefficiencies that you can exploit. So if, for example, they change the algorithm for some reason, that consensus algorithm, you can actually exploit that when the mining, it's called a hash rate. When the hash rate drops, you can then kind of attack that one and say like, oh, no one's working on this one, I'm not working on this one. So you could do it that way. So miners are more complicated than just simple brainless operation. So in that more efficient system for mining, you will kind of know when the predictability is kind of there, where you will know how much it will cost you to do a thing. barring cryptocurrencies, like I don't know if you like there was an app that became extremely popular on Ethereum maybe a year or so ago, and it just flooded the system, like overwhelmingly flooded the system to the point where the nominal transaction fee, which is typically like on the order of like fractions of a cent or like a couple cents or maybe 10 cents, went to $50 to like do a transaction. So like imagine every time you made a function call, it cost you $50. Like that was kind of the situation. So aside from like weird anomalies like that, it's pretty predictable. And so you would want to build a system that is worth doing that, like worth doing a payment for. And then furthermore, you can actually, if you're the one making that project, you can build it, architect it in such a way where your company is the one paying those fees. And so you would want to kind of obfuscate that off from the end users. So that's kind of how that works.
I'm sorry, but like, still compared to use cases where the mining report is much larger than the cost.
People cannot.
Yeah.
Yeah, because ultimately miners might, because of the reward or the value of the reward, right?
Yeah, so typically it's actually not the case where it's an obviously simple system where they're making more money today than it's costing them. So most miners are actually operating at a loss, but they're also speculating that all of these cryptocurrencies that they're buying will appreciate in value over time given a long enough period. And so that's where a lot of the value comes from. And then when the market spikes, which they kind of do artificially sometimes because they have so much sway, they will pump the market, sell off a big portion of their stuff, and then kind of like let the market do its thing.
So that's not real value, it's predicted value or somebody's not.
So that's speculation, but if you're a miner, you know that most of your money would come from speculation on the cryptocurrency.
So, would you please, if you could elaborate, if you happen to know, on the number of highly publicized Bitcoin thefts that occurred, and maybe you could give us some understanding of how that would happen in view of the fact that the system is supposedly designed to be unbreakable.
So the system is not. So the question was, there have been a bunch of very famous, very large-scale hacks or kind of flaws in the system that were exploited. And how would that happen if the system is designed to be perfect? The system is not designed to be perfect. The system is designed to do what you tell it to do. And in all of those instances, it did what it was supposed to do in code, but there was a bug in the code. So at no point was Bitcoin ever compromised. The cryptography was never broken, obviously. But it was in things like the smart contract, the most famous of which is the DAO hack, which is a financial kind of co-investment kind of situation where I don't want to think about investing, I'm just going to give my money to this thing, and this thing will make all the smart trades for me, and then I'll get rewards on it. But that got hacked, and all the money that was deposited in that got taken. And that caused something called a hard fork, where we could go into that later, but they basically quit the entire system and they started over. From like they basically restored to a save point, and then they kind of like are on a new. It's like in Avengers where there's that timeline and then something changes and they go on a different timeline. They did one of those on the blockchain. But that old timeline is still running. That's called Ethereum Classic now. So if you ever see that, that's the original Ethereum. That wouldn't reset that one big bug. But it was for like an absurd amount of money at the time. It was like a massive amount. It was like something like 30% of the entire value of the entire network was kind of in that bug. And so a lot of people wanted it to change. They wanted to reset it. I don't know if that was a question. Was there a question? Oh, like how? Yeah. So how is it doing that if it's designed to be perfect? It ran perfectly. The code that was executed on top of it was not perfect, and that's what got executed.
Yeah, sorry for the very basic question.
Thank God.
But
I'm trying to wrestle with the fact that is in a decentralized ledger system, if you will, that you're able to determine which copy of the ledger is the source of the single source of truth. Could you maybe help clarify how that is resolved?
So the short answer is it's kind of complicated and it depends on which system you're in. So as I said, there's really three kind of buckets of systems. One's a proof of work system, which is where everyone's competing. Two is kind of like, if you're invested in the system, will give you a greater chance of being selected. And then the third one is no one really decides. It doesn't matter who, because we're all equally going to be fair. And we have contracts to back that up in case anyone's being a bad actor. So I think your question really goes towards the proof of work system. Is like, how do you compete? How do you win? So the very, very dumbed down answer, like the super simplified answer that's kind of inaccurate is that let's say imagine all the possible numbers we could use in a computer. That's a lot of numbers. Imagine there's like a very tiny line, let's stack them all up. And then let's say there's a tiny line drawn across all the numbers, where everything below that line, which is a very, very tiny subset of the total numbers, there's a line drawn. And the first person to throw enough darts at that thing and land something between 0 and that line, they win. The first person that does that and can like announce that they've done it. So think of like a board game where you're like, I win, right? Like if you're the first person that says I win, and that thing then gets verified by the people around you, then all the people that have verified that you won are like, okay, you win. And then they immediately start working on the next problem while you're kind of occupied a little bit. They will move on to the next problem where you're kind of like, okay, give me my money. And so in that situation, you're happy because you got money. And they're happy because they're getting a head start over you on the next problem. And so I don't know if that answered your question, but like there's a huge amount of possible answers, and everyone's just kind of guessing random numbers. I don't know if that answers your question. So how do you know that your version is the proper version? That is actually a pretty complicated question. It's about how nodes communicate with each other. And so I don't necessarily have the technical details, but typically it's passive amongst the nodes. And then there's ways that you verify who has what, and then if everyone kind of agrees. This is actually a very in-depth engineering question. Like the way this works is very fascinating. And this is where a lot of the cryptographic attacks happen, where you can exploit a little bit of efficiency in that architecture. But it's mostly practical.
I was just curious, in all of these three, you still have miners operating?
So in the proof of work, that's the traditional miner. In proof of stake, they're still called miners, but instead of mining using that competition thing, they're mining using their wallet, which contains a cryptocurrency. And so for example, Ethereum will ultimately move to a proof of stake system. They're planning to anyway in the next several years. And so when that happens, they will no longer be competing using like hashing power and computing power. They'll just have wallets with a certain amount of Ethereum cryptocurrency in it. And the people that want to participate and want a chance at becoming the block producers of, they'll be selected to generate the next block and get rewarded for doing so. They would stake their token and they can't spend it somewhere else. You'd have to like lock it in. Yeah, but those are still collaterals.
Over here. This is a little bit tangential, but does proof of work, blockchain proliferation ever become environmentally unsustainable?
Yes.
How?
So the question was like, is proof of work, especially if you're using obscene amounts of electricity that just compete over solving a math problem, at some point does that become environmentally unsustainable? The answer is yes. I believe, I don't know the exact number, but the Bitcoin network alone one network in the cryptocurrency space uses more electricity than some countries. Now, like it's been doing that for a while. And so that is unsustainable, but they're doing a lot of things to, like they, as in the miners, are doing a lot of things because they're incentivized to not spend that much money. They're trying to make more efficient uses of their electricity. So as I mentioned, they're doing things like going towards sources of electricity to kind of use the unused electricity. They're trying their best, but it's still wasteful. And that's actually one of the reasons why a lot of proof of work systems like Ethereum are moving to proof of stake. That's one of the major reasons. Because they agree that it's not necessarily worth it, especially if they're kind of like starting to trust each other more, which is arguably a very bad thing.
Yeah, so it's becoming environmentally unsustainable. What happens to Bitcoin long term? Is there a limit to how much electricity it can use before the whole thing collapses?
I think that would eventually be an economic driving factor. So if at some point electricity becomes scarce or it becomes expensive, at some point it won't be worth it, and then the kind of your two comments kind of combine to make it not worth it to mine. But does that mean it's bad for the network? It just means the hash rate is going down. It means there's less competition to generate the block. So maybe not. So in the maybe aspect, it's like if there's only one miner, you can kind of do whatever he wants, and to like fake whatever he wants, you can generate a completely fake block with all the money in the entire system going to him, for example, and that would pass. That would be okay, because he's the only one that kind of doesn't kind of check himself, and so you don't want that, or like collusions where that can kind of happen, where there's like 2 miners or 3 miners and they're all good friends. Or like the more realistic one, it's like all the miners, like all huge numbers of miners are based in China and receive funding from the Chinese government, and they would be incentivized to collude because China is governmental. So that's a real threat.
So one of the benefits of blockchain is between digital, right? Like that's you want to store part of your life savings in the structural form that can be taken out. You can imagine, with all the benefits of fungibility, and transferability that the physical tool doesn't provide, the blockchain for actual Bitcoin.
Can you speak about the mic?
Yeah, it would be a very, very good choice. But if arguably, but if the counterpoint that you said that most of the miners are actually being sponsored by Chinese government.
Allegedly by some people. Yeah. So like we don't know. We don't know who the miners are exactly, but we can guess. And the guess is that a lot of the mining power comes from certain countries, China being one of them.
Does that dent the argument of in favor of Bitcoin being digital?
Yes, it does. It's a vulnerability that you and many people are concerned about, and so there have been attempts at fixing that and doing things to make that not be the case, but like that comes with its own problems. Like those solutions come with their own problems, and so it's usually not worth it. So everyone kind of is like, this is kind of looking for it.
So I read a provocative statement by the writers of the Wall Street Journal who've been covering this for years, and you may not know the answer, but what they said was very concise and sort of may address this gentleman's question. They said everyone's thinking in terms of the supply chain, the blockchain. What about the demand chain? Have you read about this?
I haven't, but I see where they're going.
What do you think?
So can you specify like what you mean by supply chain information?
I don't know what they mean.
Okay. So supply chain, so that's a pun that I'm hearing because supply chain, like logistics is one of the clear use cases for blockchain. And so that's kind of the poster child use case that a lot of people will use that has been done through a lot of pilot projects out of large companies. And so I think that was just a pun on the supply chain portion. But taking that, kind of breaking that down, supply chain without the chain part, the supply side of Bitcoin is no. So it was pre-programmed into the original Bitcoin code. So we know that there's a hard cap on how many Bitcoins can ever exist. 21 million, there's a hard cap. And we know exactly how we'll get to that 21 million. We know when it'll release. So every block releases 12.5. It wasn't always 12.5. But right now in the curve, it's 12.5. And after a certain point, it'll have. So people will get less because ideally those Bitcoin will be worth more. But those are all hard coded into the original Bitcoin code that everyone wrote. And so it's more just like open and it's kind of, you do the math and you see if it's worth it. And then if it's worth it, then participate. So on the supply side, that's kind of taken care of. And so that may be what you want.
That's their part.
Yeah, so the demand side is kind of the original question. It's like, who uses this? Like, why would someone use Bitcoin? And so some people use it as a store of value, like digital gold. But arguably, it's not digital gold. And arguably, it's not that safe because the prices fluctuate crazily. And it's great while it's going up, but it's terrible while it's going down. And so that's where a lot of stablecoins came from, where they were like, a lot of people actually back a few years ago, they were being paid their salary in cryptocurrencies. And that was great when it was going up, but it was terrible when it was going down. Like imagine telling your landlord that I can't pay rent because I can't convert my magic internet money for enough real dollars to give you the number that we need, right? And so a lot of that kind of turned to cryptocurrency-based stablecoins. Stablecoins are kind of like this. It's a way to keep the value of a token very similar to an arbitrary point in a certain external system. So for example, the most common one is US dollars. So it's a way to make a token worth $1 US. It's like an entire system and can get very complicated on how you like incentivize that. But there are ways to make it basically be like heavily incentivized to go back towards the dollar from both ways.
Hi, I have two questions. So the first one is, what about the opportunities for any startup companies in using cryptocurrency? Like you mentioned that the domains are mostly fintech or finance related. So I want to know like what opportunities are there and what do you think about the entry level barriers for starting any company in this field compared to any other field?
What was the second question?
Yeah, so the second one was about investing in cryptocurrency. So, what's your opinion on investing in cryptocurrency? Because for me, like, I don't know how to value it because there's no.
I'll just give you a very, the second question is very easy. It's not investment, it's speculating. So only speculate what you can afford to completely lose because chances are there will be a scenario where that drops. So it's not investment, in my opinion. It's pure speculation. And so, but speculation, you can make a lot of money speculating. So if that's worth it to you, that's kind of on you. But yeah, disclaimer, not financial advice. And the first question, what are the use cases and what are the barriers to entry? Blockchain, the technology, as I mentioned, is not that hard. It's a pretty simple programming language. If you're a programmer, you can pick up Solidity pretty quickly. And you can create your own cryptocurrency and do an ICO in 20 minutes. Right? The tech is not the hard part. I literally sat with people as they kind of, from a blank sheet, line by line, coded that out in 20 minutes. And then they were like, if I got enough people interested in this, I can now be a billionaire, right? So, but yeah, so the tech is not the hard part. The hard part is actually getting something that's useful that will answer his question on why would I use this? Right? Or like, why would anyone use this? And then making that more usable to a point where someone can understand what it does, say, hey, that's not a bad idea, and then trust it enough to actually use it. So that's our
Part of the motivation around the blockchain crypto has to do with protecting your identity, your digital identity, and the content about you on the internet so that you become the owner of your medical records. And I grant my doctor, my insurance company a license to use my data and there are 15, probably 100 different examples of that. Can you speak to those applications? And I'm curious about one of them in particular. You follow what sovereign.org is doing?
So Sovereign, SOVRIN. So they're one of many digital identity platforms. So one of the biggest, I would say, Achilles heels of blockchain right now in terms of building out like a robust ecosystem is, as you were saying, digital identity. But it's not actually about the difficulty of the tech again. It's about connecting the digital part to the real world part. So I can create you it's pretty trivial to create a system digitally that identifies a person with a username and a hash, and then makes it do something in a system. It's pretty trivial. But getting that system to actually connect to the right person and not to the person next to you or like your wife or whatever, all the time, 100% of the time, and then getting like a system of some kind, like a network of hospitals, to actually be like, that's a great idea. We trust this system over our current system. We will switch to this new system. That is not happening right now. So it's not the tech, it's the mentality around it, and like people in society that will drive when it's good enough. But it's not yet good enough by far. Yeah, I think we can kind of finish up. One thing we kind of mentioned but didn't really go into, I think is the most useful for South Bay. South Bay, these are kind of generalizations, but kind of bear with me. Enterprises, like large enterprises, like globally massive enterprises, don't mess around with public blockchains. They're very scared, or they're just completely disincentivized to use public blockchains, except for marketing, right? It's like, great, we use Ethereum to do something. That's great. But when it actually comes down to choosing a platform to build something on, even if they like blockchain, even if they think that's got potential and it's kind of neat, they won't really pull the trigger on doing a public blockchain. What they will do is do a pilot project and kind of keep it in-house, contained, so it can't do anything, but kind of let it run. And when they do that, it kind of just makes more sense not to rely on some miner in China to verify your transaction. They would rather just do it with themselves and the hospital next to you and the hospital across town. So you guys create your own little network, you guys let yourselves in, and then you keep everyone else out. But within that little ecosystem, everything works good. Everything's fast, everything's amazing, and you three benefit from your network. And then when there's a new person, you kind of let them in. Right? And so that's kind of been happening. So those pilot projects are getting traction. Everyone in the entire Bay Area has their own pilot projects for blockchain on various things. But yeah, so the trend is to use Hyperledger. And Hyperledger you may have heard of because the third one, Hyperledger Fabric, was pretty popular because IBM kind of endorsed it fully and said this is not ours, but it kind of is. But they are kind of backing that with their own kind of reputation. And because of that, they've gotten more other reputable enterprises to join in. And that's kind of been the biggest benefit of something like Hyperledger, where you're not doing the public thing, you're not doing the whole mining thing. You're kind of just using the distributed ledger part just by itself. You're kind of like extracting that cool part of it out, and just using it in instead of a database. So it's like and so I would say if you are working in an enterprise situation and you want to tinker with it, it may be worth it to try out Hyperledger because it will be more intuitive. You won't have to deal with a lot of the weird parts. And then if it works super well, then you can already just plug into a very robust network as long as you don't care about that whole censorship resistant, own your own data kind of stuff. But you can kind of get around that just like encrypting and stuff. But it's not hardcore crypto pure, but sometimes you don't need it.
Sorry, I'm not actually very familiar with this stuff. This is as basic as it gets. What does IBM do with Fabric? What is Fabric like? What do these companies use Hyperledger for?
So, so IBM doesn't necessarily own it. They're just kind of the ones that started the project. They're kind of like the ones that made the club and then invited a whole bunch of people, and then they're kind of like, it's not my club, but I know everyone here, and I invited everyone, but you know. So what they're doing is, Fabric is one version of Hyperledger. Hyperledger itself is actually not an IBM project. It's a Linux Foundation project. So it's a completely open source blockchain implementation. And there are many different flavors of that. And Fabric is just the one that IBM kind of was like, we like this one. And they kind of backed it, and then they put a really significant marketing budget behind it. And so that's why that's the most famous one, where to the point where people just think Hyperledger equals IBM. But that's not the case. And so what they would do with it is to kind of use it in lieu of Ethereum. So anything Ethereum can do, arguably, Hyperledger can do, as long as you don't need all the public stuff. Like, you don't need it to be completely trustless by anybody. You kind of are willing to just vet into the system and then use it from there. So it wouldn't be like me buying like $5 worth of Bitcoin. It would be like a hospital joining in to use like electronic medical record system. Or logistics, like Walmart doing their lettuce, that's probably Hyperledger. Or like the fish example. I think there's a few examples that I can. And then I'll send this deck out. This will answer a lot of the questions like, what are the actual use cases that people are doing? So the reason why I don't answer that like very narrowly is because there's a lot. So this one article gives 55 examples of industries and how they're using blockchain. Banking's an obvious one, I'll just go over some of them. Messaging apps, financial hedge funds, voting on the blockchain, which is actually getting pretty big. There are some countries that are actually doing their voting using a blockchain. Not many, there's a few. Identity, routing, security infrastructure. Yeah. So there's a lot of things, but so this is kind of like the vague answer that will directly answer the question like, what can you use blockchain for? You can use it for a bunch of things, but that's not really helpful. That's why I didn't answer it that way.
But I'm wondering if any of these examples are quantified, as in, for the internet advertising on this one network, they've got X many clients and their response time is so many seconds. I mean, I'm just wondering if that's done anyway.
So in that example, I guess the question was, are there any quantifiable examples of any of these things being implemented? And the example you chose was internet advertising. How is it being used? Who's using it? How much is it doing? So the biggest, I would say, internet advertising related project is called the Brave browser. I don't know if you've heard of that. Have you heard? Okay. So, hey, one person heard it. Okay. So it's basically a Chromium-based browser that was kind of taken and remodified to be very crypto-friendly. So it's a browser that you can use on your phone or your laptop or whatever. In lieu of like Google Chrome or like Firefox or Safari, you use Brave browser instead. And what Brave browser does is it has a bunch of privacy features that'll like block all the ads and stuff. But it also has a network of its own ads that is driven by a cryptocurrency incentive mechanism, where if you watch the ad, they'll pay you. Or like if you go to a certain site, they'll pay you. Or if you spend enough time looking at a thing, they'll pay you. And there are different ways to actually get that implemented. But and on the flip side, you can now just, if you don't care about being paid, a couple dollars or whatever, you can then donate to places you care about, like Wikipedia or the Internet Archive or whomever you choose to back, or like your content writer, the person that wrote the blog that you're reading. You're like, wow, this is good. Here's $1. Right? So that becomes integrated into the browser. Or like Reddit, for example, instead of giving Reddit gold, you can pay them cryptocurrencies like natively in the browser. So things like that. And so there are interesting use cases where it's not like that, it's not groundbreaking, but it's kind of neat. It's a neat little improvement on certain things in that one example. And that is backed by Brendan Knight, the Mozilla guy. So it's a pretty big project.
Sam, we're
getting towards the end. Okay, so let me just run through the rest of that really quick. This is a good video. I'll run my. So this is an example of, you can just look this up on YouTube and watch a bunch of these, where it will just walk you through how this works and how you use the blockchain in like a real world situation. I probably won't play it out because the sound's not connected, but it's not picking it up. But this is in the deck, so you can kind of watch it. So it kind of goes through like how this is like the problem, this is the current scenario, he currently uses only trusted networks of like fish vendors that he's worked with for years and who know him by face. But he wants to try different things, he wants to explore, but there's problems that kind of keep that from happening. And if it's not legit, he suffers. So use amazing blockchain stuff and IoT to track ownership over the voyage from ocean to table. That's basically that. Yeah. Anyway, but you can watch them. These videos exist for a whole bunch of things. This is one example. There's other things about like a whole bunch of examples that I'll let you guys.
So, quick question here.
Yeah.
So, when the salmon is on my plate, how do I check?
So it typically so the question is if the salmon is on my plate, how do I check? So it typically isn't you that's checking, but kind of like the biggest commercial step before you. So it'd be like the restaurant would kind of just verify something, but probably like the wholesale distributor that would kind of track the container.
I see. So basically, but the restaurant can still cheat, right?
Yes. So the restaurant can still cheat if they want to be malicious. Yes, they can. But this is why most of these are built on a permission blockchain, not a public blockchain. So that becomes less of an issue because if you cheat, then it's kind of, you're the one harming yourself. And if you're harming someone before you in the chain, they can kind of on-chain verify that you're doing so. And then they would take it. So that's why permission stuff is working in these contexts. I will blaze through the rest. There's more use cases. The public use case has been gaming because the gaming market, like owning that unique sword in the game, is important for some people. And then there's a whole bunch of other ones that I won't go into, but I will send this back out. And then the takeaways. Should you use blockchain? It depends. And so if you're the engineering leader and your use case is simple, maybe, like look into it. If it's complex and you want to change the world and change how everyone in the entire universe works, not yet, we're not there yet. And so there are risks that an engineering leader should keep in mind. It's not mature. Parts of it are mature, but it's not ready fully yet. So just be wary of just know what you're getting yourself into before you think it's going to be that that'll change everything. It may be, but it may be. The UX is a problem. Designing economics and incentives is actually pretty hard. As I said, the languages are easy and the learning curves are not bad, but adoption curves are not there yet. But if you do it right, there are a lot of benefits, including immortal projects, as long as 2 computers are up. And the trusting in a system, like a base layer system of trust, where you can kind of just rely on that. And if someone messes with that, they get punished automatically by the system. Not by you, not by a court, but it's automatic, it just happens. And then you can use blockchain in conjunction with other things like IoT stuff, machine learning stuff. There's so many other cool things that are happening in the world that are being kind of like folded into blockchain because they're incentivized to make something cool in the blockchain space. This is a very important point. I will TLDR it. There's 3 no one has figured out a way to get all three. You have to pick two. So, for example, if you want super secure and super decentralized, you cannot do it in a scalable way. That's Ethereum. If you want super scalable and super decentralized, you're gonna kind of like not do all the checking that you need to do. That's a few systems. And then like security and decentralization. We did that. So let's see, scalability and security, like super scalable and super secure. It ends up being centralized, like Hyperledger. But you can look into it. There's some really good papers on that. And if you're a business person, you have to really think about the use case that you're going after. So I know the hospital example was more of a technical question, but it's like, does it make sense, business sense, for that hospital to do that or to make that pilot program? It kind of depends, because what you get from that is not necessarily like money revenue right now. It's kind of like you get to be like, oh, we're cutting edge, right? Or like we're always on the forefront of new technology, or we're always optimizing our customers' experience or whatever, right? So it really depends. But blockchain investments are growing still, even in the down market. The amount of money coming into the investment side of blockchain is still growing. And more people that are not just cryptocurrency funds, but more like large corporate VCs, like very prominent venture, even governmental funds are getting into the game. There was an entire section that I could talk about on like blockchain and law and how that affects all of this, but I will just skip that for now. And if you're a developer and you're just kind of like, should I learn how to code blockchain stuff? I would say, yeah, go for it. It's really not that hard. You can probably learn it in a day. Or to like master it, maybe like a week or two, or like a month or whatever. But it's not super hard. It's not like learning an entire new program, which even though you kind of do that, but it's not that weird. It's pretty intuitive. But the hard part is actually more architecting things in your head, kind of knowing where this thing goes once I kind of send it. Like, where am I sending it? You know, things like that. But yeah. There's a bunch of additional resources, and then this is it. So, yeah.
Hi. Just to get a sense of where you are in your development process, we know that Linux is pretty far along because there's an NSA version of Linux called Secure Linux. So I was wondering, is there an NSA version of blockchain? What is it called?
I don't know. I think you guys heard it, but I don't know if there is like a government-sanctioned blockchain, but there are government-sanctioned cryptocurrencies. So a lot of countries actually have developed their own national cryptocurrencies. Everyone on the right. And then everyone at the bottom are looking to do it, to see if it's viable. They're kind of tinkering with it. So it's possible.
Thank you, Sam, and everyone, please thank Sam. Now we'll do our wrap up.
All right. Well, I learned a lot. That was pretty cool. So yeah, we're wrapping up here. We've got until we got to kick everyone out the door by 9 o'clock. But we do encourage everyone to stick around, socialize a little bit, network, come talk to Sam, talk to John, our sponsors from tonight. But then also we really do want SVELC to be a resource for not just community knowledge, but also to network and share those kinds of things. And so we open the floor for the end. If anyone is either looking for a job or is looking to fill a role, we would love to hear from you. It takes a brave person to stand up and volunteer for that, but I promise if you fill that role or you find yourself a job, you will be grateful. Anyone that would be interested in speaking on that? Yeah, here you go.
Yeah, hi, I'm Matt Murray, and I work at Knock Labs. And we build technology that allows for passwordless authentication. And we're looking for a senior product manager that has a background in identity and access management. And so if you have that background, or you know someone who does, come see me. Thank you.
Cool, thanks, Matt. Anybody else?
So I'm currently, as I call, a free agent. So I'm looking for the next place to hang my hat. I typically do operations at early stage medical device typically. And I do project management, so I'm certified in the new methodologies. And so I try to bring products from the development phase all the way through into operations and supply chain.
Thanks, Larry. Anyone else?
So I'll pop up with one. I'm helping a friend over at EdCast, and they're growing fast in what's called the learning experience platform. And they are looking for someone to run product management for their whole company. They have about 350 people, and they're adding 20 to 50 people a month right now. So it's growing fast.
If they need a good
My name is Paul Gustafson. I run a company called Expert Support, and Grant's my partner. We are always looking for technical writers in the software and systems administration and user people who can do technical documentation. And in the last year, we've also expanded practice into both UX writing and UX design. So we have a growing number of good candidates in that field, so if we need help with either of those things, we have good pipeline candidates and always looking for new assignments too. So, and we have some work on blockchain documentation too. So that's it for me.
One of my friends, she is a recruiter and she is looking for a job. So, technical recruiter. If anybody has a company who needs technical recruiter, it's not for me, for one of my friends actually.
That's fine.
All right, well, we're all finished then. Again, we gotta be out by 9. To the extent that you're only unable, if you could help move chairs back 2 tables. But thank you guys all so much for coming. And don't forget the book swap. And next month's meet is not a usual one because of the holidays. It's gonna be our holiday meet, which is mostly networking and food and stuff like that. Cool, thanks again, guys.
Thank you for coming.